don't know if it's right.
Did 81, did you get 1? Did you get 1?
81, move the 1 over. And now I gotta do some grouping. 4 terms. Usually it's you group it when you have a x cubed, but in this case you can take out x cubed in the first and get x plus 1. Here I can take out a -1 and I get x plus 1. So I have x cubed minus 1, x plus 1, which means here I can factor that further
Oh, nuts.
because you get your x minus 1, x squared plus x plus 1, x plus 1, and 0.
Sure.
It's a difference of cubes. 1 is a perfect cube root. Negative, and x cubed is a cube root. Yes, ma'am?
I don't understand that last part you just did at all.
I factored a difference of cubes. The difference of cubes, remember we had a cubed minus b cubed equals a minus b, a squared plus ab plus b squared.
I don't know.
In this case then, you're only going to get the real solutions here at 1 and -1. This one you'd have to use quadratic formula to get the imaginary solution. But since it said just real, you don't have to worry.
I'm just gonna put across.
Yeah, 2 reals. Yes, sir.
39.
Wait, Mr. Murphy,
Yes, ma'am.
I have a question, because if you didn't factor out the last one, but you still get the same zeros, does that work every time?
What happens is it's not so much that it's always going to work like that. You have to. It worked because it was looking for real. When I start saying find all, you have to do this step to get to this part.
Okay.
Okay. It's just that's why that's why I'm showing it so that way when you see that all zeros, then you'll know.
Okay.
GCF 4. Take out the 4, and I get 8x cubed minus 1, and now we're back to a difference of cubes. So the cube root of 8x cubed is 2x minus 1. Then I get 4x squared minus 8x. Hi! Whoa, there's 3 of you. I don't have anything for you though.
It's totally okay.
Stand up. Let's see how long we can hold our handshake. Come on, let's snap. Uh-oh. You guys know Dwayne?
Yeah.
Now I don't know him very well.
What's -1 squared?
He put me on the spot. I have to think about it. 1.
For sure. See you, Dwayne.
Yeah, no. That's gross.
And you wind up with that. That's Dwayne. Dwayne's a good guy.
I have a couple questions.
Oh, yeah.
Wait, what? Thank you. Sorry. Yeah. Yes. I accidentally erased it.
Shouldn't it be 2x squared?
No, because this part here, this is your value of a is 2x. Square it, you get 4x squared.
Oh, done.
Okay.
Okay.
You have to make sure you square that coefficient as well. Yes, ma'am? No, because when you get into that one, what times what's 4 you add together to get 2? Whole lot of nothing. Usually what happens when you factor a difference of cubes or a sum of cubes, the trinomial that you come up with is going to give you an imaginary solution. It's usually going to be an unfactorable setup. So at that point, if it says find all real, you don't have to worry. When it gets to find all, then you'll use quadratic formula at that spot. Abby, I'll get you next to this spot.
I have 60 and 66. So.
What's first rule of factoring?
GCF.
What's the GCF?
3x.
Okay?
Yeah, no
What
joke
times
with
what's
that.
10 you add together to get 7? You should be able to finish it out from there.
It's like group them.
Yep.
Dang it. What do you do with the 3 though? Like, does that just go away?
GCFs. No, nothing's going away. You're doing GCFs.
Oh.
So your final factored form would be 3x, 2x plus 5, and x plus 1. Zeros at 0, negative 5 halves, and negative 1. Which way are the tails going in this one? Down, up?
And then I had 66 as well.
It would look like that. Exciting.
Because he did the 2 times the 5 to equal the 10.
Ms. Blackwood, which one did you have? What times what's 30 you add together to get 31? There you go.
But that's it. What? I was right. Gosh, dang it. Please stop. Please stop.
And then do your GCFs again. Remember, guys, if it's written that looks like a trinomial where the first degree, the first highest degree, and the next one is half of it, you treat it the same way. GCF gives you a 5x squared, x squared plus 6 plus 1, x squared plus 6, gives you terms of 5x squared plus 1, x squared plus 6, and you're done. You cannot factor that any further. You're going to get all sorts of imaginary roots in this one. What? What? What did I say?
Wait.
What's the first rule of factoring?
Move it over.
Just turn it around.
I'm done. I'm gonna go start crying for this. I fucking hate this guy.
That has to equal 0, doesn't it? Okay. This goes along for the ride.
This goes on. Just kidding.
Eventually.
That's
Might as
the
well try
magic.
once. What's 9 minus 36? Yeah, negative, yeah. Sorry, I was thinking negative 27. What's the square root of negative 27?
5 root 27. No, that's not.
What's the square root of 27? 3 root 3, so this is going to be
Wait. See? Oh,
Yep, that's exactly what I got.
I don't know where you got the 4 from. I just tried to ignore it for a while. Yes, ma'am.
It's not possible.
Remember, it's got a 7-degree polynomial, which means you can have up to 7 zeros. It has a multiplicity of 4 at 0, one other real solution at 3, so that makes 5. Then you have 2 other imaginary solutions. Is that it?
Yeah.
There's 2 real. One of them has a multiplicity of 4, which makes a total of 5. And then you have 2 imaginary. means there's 7. Ooh, you ugly! Nasty! I love it. Oh, the uglier, the nastier, the problem they have here. Speaking of ugly and nasty, Mr. Noah. Oh, too easy. Sorry. It's what? Oh, yeah, I'm just a little bit taller. Mr. Noah, what do you got?
And I just started driving my car.
Oh, I didn't ask if you were good. I thought you had a question.
78.
Thought you-
78.
I apologize if I hurt your fragile feeling. I'm very upset right now because I ran out of coffee. I usually have coffee still. I must have just drank it too fast. Go ahead.
You have it fully factored
Yeah.
out, and you have the x squared, x, and like x squared, 3x, and you have to use the quadratic formula.
Yeah, if I ask you to find all real, I mean, it's not all real. If I ask you to find all possible zeros, when you get to the point here and you see it's +9 to get you 3, you know nothing's going to work. That's when you have to use the quadratic formula to get you those other imaginary roots. But I think in the homework here today was all just find the reals. Okay. Yes, ma'am.
Will they always be imaginary if you use the quadratic?
Not necessarily. Remember, quadratic formula will always work. It's just usually that when you have a sum or a difference of cubes, it's usually an imaginary root thrown in there with that. That's why. Okay. You don't always have to. I mean, you might get something that is factorable. Don't pigeonhole it that it's always going to be like that, because when we get into some of the stuff that's going to look like, what section is it? I think it's this one. When we get into stuff like this, where we're going to find all the, don't we have any upward agreements? When we're going to be able to look at stuff like this. By doing something totally different. I mean, for here, there's no grouping, there's no step, there's 5 terms thrown in there, but you can still factor it. And the way that we're going to factor it is utilizing that. Yes, ma'am.
Can you do 78 next week?
This section is difficult.
You said 75?
78.
So right off the bat, I got to move that 16x over. Move the 16x over, and I take out an x, and we get x squared plus 8x plus 16. What times what 16? You had to go get 8. You're done.
That's what I thought, just check.
Now this one is a very easy one to graph and show tails. We know that it's an x cubed, positive first term, odd exponent, so we are down up. I have zeros at 0 and -4. Multiplicity at -4, which means what does it do at that axis point? It just changes direction at that spot, exactly. So I know that if I'm going to graph this, which I'm probably going to have you do, that means it's increasing, changes direction here, and then comes back up.
How do you know this? This is just 2.
What's that? Remember we talked about that whole, if you have a repeated 0, if it's repeated twice, it's got a multiplicity. And if it's repeated just twice, if that means it's touching the axis to change direction at the axis, as said going through it. Sorry?
It has like a multiplicity of 3, does it touch it 3 times?
No, what happens is it gets a little bit weirder, and that's stuff we'll do in pre-cal. So I wouldn't worry about it. Whenever I have you guys graph things like this, if there is a multiplicity, I'll have it just set it at a 2. I won't make you go any crazier than that. I can, but meh. It's exciting. What else got? Now that we've done the all of it. So quiz then. Yeah, that quiz would be over 6-1 through 6-4. Very straightforward.
I have to relearn that.
Maybe rough sketching like this, probably.
No,
Okay.
thanks.
Yes, ma'am.
But flexibility will make it up here tomorrow.
And we're gonna cry. Ever so slightly.
I'm not gonna be here.
Not really though. Sir.
Well, the synthetic division beyond.
Maybe or maybe not.
I hate
That's
that.
just 5, so.
No, actually synthetic, we started doing synthetic in 6-3. We use synthetic in 6-5 to do, like I was saying here, we'll use it to factor. Okay, so we use synthetic division in order to find factors, and we're using synthetic just real fast. So if you go back and you think about what did synthetic look
I like
like.
the synthetic stuff.
Synthetic's awesome. I love synthetic division. Where is my number 6?
What?
I'm a lot of focus because I've been not my favorite.
If I'm using synthetic division, synthetic division is a method of substitution, okay? And if they're asking you to use synthetic division to evaluate a polynomial at a specific value, what you're doing here is you're using all the coefficients in descending order as well as any placeholders that might be there. For example, if I'm looking at number 25 here, I have cube, squared, x, and then a constant. I don't need any placeholders, so all I do is pluck out the coefficients. 2, 3, -5, 1. Synthetically dividing by 2. Your first step is, then what? Then what? You're done.
That's all we need, it's 19.
Yep, because what happens is when you substitute in 2 into this equation, you get 19. That's what that means. Now, when we get into 6-5, like you're alluding to, is that we're going to be able to take a string like this, list all the possible factors of the tails. What are your factors with 8? 1, 2, 4, and 8, right? What are your factors with 1? 1. So you can have plus minus 1, 2, 4, and 8. Because I can have -1 times -8 and so on. Or positive and positive 8, right? So what I do then is I'm going to take and go through this list to find something that gives me 0 at the end. So we'll start with 1. It might, but if you have a pencil, you just erase it. Seriously, it is. You get to be so fast at this. 1, 1, 2, 2, 4, 4, 8, 8, 0. Look at that, I found one. So if it was luck, that was.
That's not cool.
It happens, but not always. So if 1 is a 0, what's your term? X minus 1. That tells me that x minus 1 is a factorable term of x to the 4th x cubed. But what's nice is that each time you synthetically divide, you drop a degree. So this becomes now x cubed plus 2x squared plus 4x plus 8. And if you look at that, you might recognize that you'll be able to group it because you now have a cubic term, 4 parts, and I can get GCFs to finish that out. So synthetic division allows you to get that out real quick because this is all positives. Those are just coefficients. So you get x squared, x plus 2. Take out a 4 and x plus 2. So you factor it out, you get x minus 1, x squared plus 4, and x plus 2. If I want to find all of the zeros then, it's 1 plus minus 2i and -2. But what allows you to do that is the synthetic division. Synthetic division is awesome. You can do so much with it, okay? But all you're doing for tomorrow-wise is using it for substitution. just so you get the hang of it. Like I said, synthetic substitution, synthetic division is really quite simple to use. It's just a matter of It's just a matter of doing it enough, that's all. So look at 26. You want you to synthetically divide with -1. You've got 10x cubed minus 5x squared plus 4. If it's a cubic problem, how many terms should I have? Should I have 4. This one only has 3 of them, which means I need placeholders. Where do I put the placeholder? Where the x would be, right? If we keep it in that descending order. So it would be 10, -5, 0, and 4. And I do the same thing. 10, multiply, add, multiply, add, multiply, add. So I know -1 is not a 0 of that, and so on. So
What was 6-1 exactly?
6-1 was all those exponent rules. 6-1 goes back to all of your exponent rules. For example, why don't you take a second and simplify these two? 6-1, isn't it? So take a second and simplify these two as far as exponent rules. Yes, sir.
I just have a question.
See how we did. First one, what you want to do is remember, does the -4 get squared? No, because it's not in the parentheses, so just leave it out there. So you have -4, x to the -10th, y to the 4th. Which one of those is happy? Or not happy, excuse me. X to the -10th. The -4 is okay because the exponent is positive, just a negative number. So you have -4y to the 4th over x to the 10th. Okay? On the second one, you'll notice that the 2/3 cannot be simplified, so you just write down 2/3. And then what I would do before I try to simplify anything, make everything happy. X to the 6th, y to the 3rd, x cubed, y to the 5th. Then play your game of war. You should have gotten 2x to the 3rd over 3y squared. Yes, ma'am.
The -4 doesn't go with y. On 18.
-4 goes to the y. It's -4y squared because that's all the numerator.
Wait a second.
It's in the numerator.
No, I know, but I'm talking about like in the beginning, it would be -4x and -4y.
Because it's x and y.
No, because it's junked inside there because there's no addition between the two. So think of it as 2 times 3 times 4 is 2 times 3, 2 times 4, because there's no plus in these. Okay. After that, we did that. Graphing we know how to do with our tails. Adding and subtracting, the biggest mistake you're going to make is subtraction because you're not going to distribute the negative. Multiplying is just a matter of taking your time. And then factoring. I mean, I don't know what else to throw at you guys here. Oh, and that's 6-1? I mean, do the same thing. First thing you would do, come on guys. First thing you would do in that first one, distribute the -8 as an exponent. Now the 6 has to be raised to the -8 power because it's inside the parentheses this time. So you wind up with 6 to the -8. X to the -3 times to the -8 is x to the 24th, and then y to the 8th. Now, the only one of those that's unhappy is the 6. So you can just rewrite that as x to the 24th, y to the 8th, over 6 to the 8th. I don't know what that is. It's got to be some very large number. There you go. 68th is fine, because you might not get a calculator.
Okay, so we don't have to do that
This is like
mathematically.
real.
You can go charge it.
Is this gonna be here tomorrow?
Do you need it for later on today? Or just throw on the charger, pick it up later. Second one, put all your numbers together first before you try to do anything. Actually, you might be able to do this in your head. 8 goes into 16 how many times? 5 goes into 15, 3. Your numerator becomes 6. X to the 5th, I get x to the 6th. Y to the 4th, y to the 2nd, y to the 6th. X to the 3rd. What's y to the 0?
0.
1.
Do these Dewey, like tomorrow?
And then you just rewrite. Play war. We have 6x cubed y squared, and I didn't even need the fraction bar. If you throw it in there, it's not a big deal. Must be 10 o'clock Tuesday, first Tuesday of the month.
Yep.
To be honest with you, I can't. Aside from, if I have you guys find zeros and graph via the tails, that's about the only thing that's not in the book. Because that's just that couple of little extra steps that I threw at you guys.
Will there be graphing?
No. Everybody else but you know.
Mr. Murphy, how'd
Lucky.
you get 2 for like that?
6 and 4. Who wins?
L6.
No, like up above.
She's
8 goes into 16 how many times?
Okay, that's cross.
I'm not cross multiplying. No.
Cross-dividing.
I'm not cross dividing. Nothing. I am simplifying a fraction. There's no cross multiplying. Cross multiplying is when fraction equal fraction. There's no fraction equal fraction. It's just simplifying. Okay, that's all it is. Okay. To be honest with you, I would, if I were you, spend some time going over the stuff out of the back of the book, the extra practice. I mean, it's page number is what, 947. I did a bunch of the factoring ones from last night. If you need more practice on there, there's some of those in here as well. Bless you. It's telling you to find all the real zero. Oh, sorry, that's 6. Here you're just talking about the factoring on 6-4. So a lot of that's just going to be your grouping, GCFs, and having to know how to factor via the difference in sum of cubes. So that's.
Get the formulas for those.
1, 0, 3.
Oh, no.
Oh, okay. So it's just one.
Well, that's how I roll. So, what else you want to see? Well, we got a couple minutes here.
What about a few more problems of what we did from last night? Because I was confused on those.
Specific? I mean, you can pick one or pick one out there.
Can I see the answer to the test?
If I had it,
More problems.
not all done yet. What's that?
Some more example problems from 6.4.
Well, there are some. Which one do you want to look at?
Is this last night's homework?
What's the same stuff?
Yeah? I don't care. What site do we need to know, Mr. Murphy? What's the good one? The 7.
Do that.
Did we do that one?
We'll make this interesting. Let's say this says equals 0. All right. What's your first rule of factoring? Would always go to GCF. Obviously, in this one there is not a GCF. Come on, guys. Since this is a 4-term polynomial cubic function, that's usually forcing you to try to see if you can group it. So you group them. Look at the GCF of the first 2 terms. What is it? 2x squared. If I take out a 2x squared, I'm left with x plus 9. The next one, I'll take out the negative 5, and I have x plus 9. Okay? My 2 terms then become 2x squared minus 5 and x plus 9. What's that? So my zeros are going to be negative 9, and then this one, I get 2x squared, bless you, minus 5 equals 0. Add 5 divided by 2, I get x squared equals 5 halves. Then I take the square root of it. So I get x equals plus minus the square root of 5 over the square root of 2, which means you can't have the square root of the denominators. What do you multiply top and bottom by?
Root 2.
Root 2. Yeah.
Well, that's really complicated.
So you get plus minus root 10 over 2. So those are your 3 zeros.
3 zeros.
Plus
That's
or
a cubic
minus.
function.
Yeah.
Okay.
Oh,
It's-
plus minus that.
Excuse me. I'm trying to think what else there is. Really no tricks. The tricks really start coming when we start learning about upper degree polynomials, so. It's good times.
Do you have any flex pencils?
I love it.